Hi, we're taking a look at section 8.4 and question number 4 on page 534. Oops, 534. From 10 employees, how many ways can you select a group of 4, assign 4 different jobs? Well, if we select a group of 4, any 4, then what we have is order is not important. Therefore, it'll be a combination. It'll be a combination. So let's take a look at A. Okay, so what we have from 10 different employees, we choose 4. And you can put this in the calculator like that and you'll get the same result. But with your combination formula, you have 10 factorial over 6 factorial, 4 factorial. Okay, what we have here is 10 by 9 by 8. I'll write it out. I think you can use your calculators to get the calculator to do the work. All over 6 factorial, 4, 3, 2, and 1. So it's n factorial over n minus r factorial. So let's just put this here, n factorial over n minus r factorial, That's we're using that formula, the combination formula. And remember, for combination, order is not important. Now, you know when you have a combination lock, it should be called a permutation lock, because a permutation lock would mean order is important. And when you have to break or open that lock, the order that you enter the numbers in are important. So it should be called a permutation lock. That's not a combination lock. Okay, let's take a look at assign 4 different jobs. So for 4 different jobs, well, if we take a look at B, here, order is important. So we are going to use permutations. So we have 10, pick 4, is equal to 10 factorial over 6 factorial. So essentially we have NPR, hopefully you remember, equals n factorial over n minus r factorial. Okay, and my n is 10 here and my r is 4. So when we simplify, you just put this in the graphing calculator. The thing I would suggest you do if you're going to take a look at it by actually calculating it arithmetically is make sure you put these in brackets. Don't forget to do that. So what we have is 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial. Beautiful. I forgot to put here what this is equal to is 210. And what the permutations, the number of permutations are where order is important, is 5,040. Okay, so that's just very simple examples. Now we're here to solve for n. Now, I need you to remember that NCR equals n factorial over n minus r factorial r factorial. Okay, so we're basically substituting. So wherever we see the number on the left, that substitutes for n, and the number on the right of the c, we substitute that value for r. That's all. So here for A, we have NC1 equals 10. Well, this is kind of coincidental. We have NC1, we have n factorial over n minus 1 factorial, 1 factorial equals 10. Well, I'm just cross multiplying with that one. We end up with n factorial over n minus 1 factorial equals 10. Now I need you to know, remember we simplify the larger of the two terms. N factorial is larger than n minus 1 factorial. If n was 5, it would be 5 factorial, and we'd have on the bottom 5 minus 1, which would be 4 factorial. So n factorial is definitely larger. So what we have is n by n minus 1 factorial over n minus 1 factorial equals 10. And beautifully, these cancel out, and we end up with n equals 10. That's for A. Let's take a look at B. Use a different color. Okay, and we have NC2 equals 21. Okay, NC2 equals 21. Well, we have n factorial over n minus 2 factorial, 2 factorial equals 21. So 2 factorial times 21 is n factorial over n minus 2 factorial equals 2 times 21 is 42. Okay, again, we expand the larger of the two terms. So I have n by n minus 1 by n minus 2 factorial over n minus 2 factorial equals 42. Okay, so these will cancel out, and I get n squared minus n minus 42 equals 0. Looks like an H, I better fix that. Factoring that out, we have n minus 7 by n plus 6 equals 0, n equals 7, n equals negative 6. Now the values in our combination cannot be negative, therefore it is 7. Or you could say n has to be greater than 2. So therefore the n equals negative 6 is inadmissible. Okay, let's try another one. C, NC2 equals, oops, n by n minus 2, C n minus 2 equals 6. Okay, same process, but this time for my n, I have n, but for my r, I have n minus 2. So what I have is n factorial over n minus r, which is n minus 2, factorial, n minus 2 factorial equals 6. Okay, well, n minus n plus 2, I guess I can put that step in, n factorial over n minus n plus 2 factorial by n minus 2 factorial equals 6. And that's beautiful. We have 2 factorial by n minus 2 factorial equals 6. Should all be over n, sorry. So we will have oh, that's wrong. I'm sorry, guys. I'm going to go here. If we take a look, n over n minus n plus 2 by n minus 2 factorial will indeed be, let's just clean that up, n factorial over 2 factorial n minus 2 factorial equals 6. Well, 2 factorial times 6, we can get the n minus 2's to cancel out. Let's do that first. We're going to have to expand. So I have n by n minus 1 by n minus 2 factorial over n minus 2 factorial. And I'm just going to multiply that 6 by 2 right now. 2 factorial to get 12. Just thinking about that earlier. These will cancel out. And what we have is we have n squared minus n minus 12 equals 0. Well, that's n minus 4 by n plus 3 equals 0. N equals 4, or n equals negative 3. And the negative 3 is inadmissible. Because we can't have a negative value for n. Okay, so let's take a look at the last one. Hopefully I'm not going over time, but you guys can skip through. We'll take a look at D. And what we have is we have n plus 1, C, n minus 1 equals 15. Now remember, this is my n value in my formula, and this is my r value in the formula. So it gets a little bit crowded. So what I have in the numerator is n plus 1 factorial all over n plus 1 minus n minus 1. And this is all, I should erase this, n plus 1 minus n minus 1. And I should put all of this as a factorial by n minus 1 factorial equals 15. Well, when we simplify all this out, we have minus n, we have plus 1, so we end up with, in the denominator, 2 factorial n minus 1 factorial, and in the numerator, we have n plus 1 factorial equals 15. So again, we're going to expand the larger, and we have n plus 1 by n plus 0, which is just n, by n minus 1 factorial over n minus 1 factorial equals 30. 15 by 2 factorial. Okay, well, beauty of this is these two cancel out, and we end up with n squared plus n minus 30 equals 0. So we have this, and we end up with n plus 6 when we factor it. N minus 5 equals 0 by the zero property principle. N equals negative 6, n equals 5. And this is inadmissible. Okay. That's it for questions 4 and 6.